Solve by substitution. Y equals 1/2 x plus 6, and 4y minus 2x equals 6. In this problem, one of the variables is already isolated. Y equals 1/2 x plus 6. Now, we might not be happy that there's a fraction in that equation, but we can still make a substitution. Wherever we see a y in the other equation, we can replace it with 1/2 x plus 6. Let's do this. We've got 4 times y, where y was 1/2 x plus 6, minus 2x equals 6. On the left, we're going to have to distribute that 4. 4 times 1/2 x is 2x, and 4 times 6 is 24. So we've got 2x plus 24 minus 2x equals 6. Now, we can combine like terms on the left-hand side, but 2x minus 2x is 0. They go away. So all we're left with on the left is 24, and on the right, we're left with 6. And this is another one of those situations where the variable has disappeared, but unlike the last situation where we had a true equation, now we have a false equation. We have an equation that's never true. It's never true that 24 equals 6. Now, in the past, in a situation like this, we would say no solution. And in this case, that is actually what we're going to do as well. Remember when we were graphing and we ended up with parallel lines, there were no solution. This false equation is what happens in a substitution problem that corresponds to what we would have if we had parallel lines in a graphing problem. So if we had graphed this, we'd have parallel lines. We'd have 2 lines that were parallel, and those lines would never intersect, which means that there would be no solution. And that's the conclusion we're going to draw here. But instead of going through all of the steps of graphing them, what we're going to do is we're going to recognize that when we're using substitution, if you ever end up with a false equation where the variable goes away, and you've got something like 24 equals 6, or 2 equals 3, or 0 equals 8, that corresponds to the situation where they're parallel, and in that case, we're just going to say there is no solution.